Okay. Now here we have y is equal to root 2x plus 3 raised to 2x. So hence, what do we get? Now here I just want to clarify, this should be root 2x. So to be on the safer side, we can write it as y is equal to root 2 into root x plus 3 raised to 2x. So dy by dx obviously would be root 2 upon 1 upon 2 root x, that is x raised to half, so it's half x raised to, so it's going to be 2 root x, and the derivative of 3 raised to 2x is 3 raised to 2x into log 3, right? So this of course can become root 2, so ultimately it's 1 upon root 2x plus 3 raised to 2x, and then of course we also need to find the derivative of this 2x, which is 2. So 2 into 3 raised to 2x into log 3. So yes, this is something which we skip. We first find 3 raised to 2x into log 3. Then since this is not 3 raised to x, we need to find the derivative of 2x, that is 2. So it's eventually 1 upon root 2x plus 2 into 3 raised to 2x into log 3. So let's see whether we have this here. Yes, this is this one. Of course, remember it's log 3 to the base e, which is understood. Okay. So it's option number A. Okay, so we do have that. Okay. Then we have, of course, this one. We have done this type of a sum. It's e raised to 3x square. Yes, y is equal to e raised to 3x square minus 6x plus 2. Obviously, dy by dx is going to be the same function. E raised to 3x square minus 6x plus 2 into derivative of this, that is 6x minus 6, which can be written as 6 can be taken out common. So you get 6 bracket x minus 1 into e raised to 3x square minus 6x plus 2. So which is option number C. Okay, yes we do, right? Okay, so what do we have next here? It's f of x here, root x plus 1. Now this could be a little confusing. What it's meant is root x plus 1 upon root x. So it's somewhat like this. Root x plus 1 upon root x, the whole square. Sorry, this is square. So f dash x has to be first u, this is u, suppose, so u square, so it's 2u, that is root x plus 1 upon root x raised to 2 minus 1, and then d by dx of this, d by dx of root x is 1 upon 2 root x, and d by dx of 1 upon root x, if you remember, this can be written as x raised to minus half. So it's going to be minus half x raised to minus 3 by 2, which is x root x. So it's going to be this way. Now if you take out 2 common outside, you can write it as 2 into root x plus 1 by root x into half into 1 upon root x minus 1 upon x root x. So you cancel away this. Now you have been asked to find f dash 2 would be root x. What is root x? Root x is f dash 2. Root 2 plus 1 by root 2 into 1 by root 2 minus 1 upon 2 root 2. You can take LCM. So this will turn out to be 2 plus 1 upon root 2 into LCM is 2 root 2, 2 minus 1. So ultimately this turns out to be 3 upon root 2 into 2 root 2 is 2 root 2 square into 1, which is 3 by 4. So ultimately it is 3 by 4. That is option number 8. Okay. Alright. Now here you have another interesting thing. Y is equal to root x square plus m square. Then y1, where y1 is dy by dx. So ultimately you need to find dy by dx and multiply it with root x square plus m square and see what we get. So y is root x square plus m square. So we can call this as equation number 1. So dy by dx, which can also be called as y1, is nothing but root of x square plus m square, which is nothing but 1 upon 2 root x square plus m square. Remember, y is equal to u raised to half, so 1 upon 2u raised to half minus 1 into derivative of x square plus m square, which is 2x, so this gets cancelled. So y1 is equal to this. So if you multiply y into y1, you get what? Root x square plus m square into x upon root x square plus m square. This is cancelled, hence y1 is x. So among these, x is the correct answer. So let's check this. Yes, we do have it right. All right. Now, here you have y is equal to e raised to root 2x. So what do we have here? So y is e raised to root 2x. So dy by dx is as the composite function. It's e raised to a variable. It still remains root 2x. And then d by dx of root 2 into root x, which can be written as e raised to root 2x into root 2 into 1 upon 2 root x, which eventually would be root 2x. So it is e raised to root 2x upon root 2x. So dy by dx is going to be e raised to root 2x upon root 2x, which is, we have two answers here, so we could take this A as the correct answer. Alright. Okay. Here we have x plus root x square minus 1 raised to m, then x square minus 1 into dy by dx, the whole square minus m square y square is proved to be 1. Okay, so let's see this. It seems to be a very interesting one, so we'll have to make a lot of space for you people. So maybe we will put something like this here. So you have y is equal to x plus root x squared minus 1 raised to m. Okay, right. So now, hence, dy by dx is equal to m into x plus root x square minus 1 raised to m minus 1 into derivative of this, so 1 plus 1 upon root x, 2 root x square minus 1, that is u raised to half, so 1 upon 2 root u, and then derivative of x square minus 1, that is 2x, so this gets cancelled. So ultimately this is m into x plus root x square minus 1 m minus 1, and here if you take LCM you get root x square minus 1 plus x upon root x square minus 1. This alone and this are one and the same, so this will turn out to be m into x plus root x square minus 1 raised to m minus 1 plus 1 upon root x square minus 1. So ultimately, dy by dx is nothing but m into x plus root x square minus 1 square raised to m is nothing but y. We can write it as my upon root x square minus 1. Now look at what we have. We have to prove this. It's quite clear. You need to square both sides. When you square both sides, we get dy by dx, the whole square, is equal to m square y square upon x square minus 1. Simplify it, you get x square minus 1 into dy by dx, the whole square, minus m square y square, obviously will be 0. Right? Remember, dy by dx, the whole square, I mentioned earlier when we introduced the concept, is not equal to d square y by dx square. dy by dx is you find the derivative and then square that particular expression. Whereas d square y by dx square is you first find the derivative and then find the derivative once more. That is the second derivative, which is d square y by dx square. Anyways, our right man seems to be this. So hence the value of this is 0. Okay. Alright. Now we have a very interesting thing over here. You have log e raised to x is so and so. Okay. So let's simplify this. So y is nothing but log of e raised to x into x minus 2 raised to 3 by 4 the whole. So hence this will also be x plus 2 raised to 3 by 4. So we use the rules of logarithms here. So eventually y will turn out to be log a into b. So which is going to be log a plus log b. But log a by b is also log a minus log b. So this will give you log x plus 2 raised to 3 by 4. Further we simplify, log of a raised to m is nothing but m log a. So hence this becomes x log e plus 3 by 4 log x minus 2 minus 3 by 4 log x plus 2. Alright. Now the entire expression has been neatly converted into a simple expression. We can find dy by dx, which is nothing but log e is a constant into x. So it's going to be, hence we have, if you take either ways, you'll end up getting, if you use the chain rule, log e raised to x. Log e to the base e in any case is going to be 1. So it's going to be x into 1. Okay, let's write this as x into 1 plus whatsoever, all these things. Log e to the base e is 1. So derivative x log e to the base e is basically x into 1x. So derivative of x is 1 plus 3 by 4 into derivative of log x minus 2 is 1 upon x minus 2 into derivative of x minus 2, which is 1. It's not needed to do. Minus 3 by 4 into derivative of log x plus 2 is 1 upon x plus 2 into derivative of x plus 2, which is 1. So which is eventually 1 plus 3 upon 4 x minus 2 minus 3 upon 4 x plus 2. Taking LCM is 4 into x minus 2 into x plus 2 is x square minus 4. This again would become 4 into x square minus 4 plus 3 into x plus 2 minus 3 into x minus 2. We need to simplify this. Let's see what we get. So this turns out to be 4x square minus 16 plus 3x plus 6 minus 3x plus 6 upon 4 bracket x square minus 4. So we have these fellows that can cancel. So minus 16 plus 12 minus 4. So we get 4x square minus 4 upon 4 bracket x square minus 4, which easily simplifies to 4 bracket x square minus 1 upon 4 bracket x square minus 4. This gets cancelled and ultimately you get x square minus 1 upon x square minus 4. So among these options we have a man here, x square minus 1 upon x square minus 4. So option number is B.